Hello, hi everyone. Good morning and welcome to this session by OneClass. My name is Nehel and today we'll be covering some popular physics questions. So these questions would range from uh, senior school, high school to university level questions. Um, just a little bit about myself. I graduated from University of Waterloo in 2018. I studied mechanical engineering there. As after graduating, I have been working for about 2 years, 2.5 years now, and I'm looking forward to starting my master's degree at University of Toronto, also in mechanical engineering from January. So looking forward to that. All right, so without further ado, let's get into it. Okay, so question one for today is, what is the magnitude of acceleration for speeding up phase? So we're given velocity and time curve, and we need to find the magnitude of acceleration for the speeding up phase only. So just to be careful here, acceleration has, obviously being a vector quantity, it has two phases. One would be accelerating and the other would be decelerating. So in this plot, we have a line here and then a bump here and then a fatter tail here. And this point is 0.2 and then this point is 0.4, and it takes us a little bit less than 1 second to get to that point. Or sorry, the velocity is a little bit less than 1 meters per second. Okay, so in order to do this question, we need to know first of all what the formula for acceleration is. So acceleration is nothing but the rate of change of velocity. So from the definition, we would say that acceleration is nothing but the rate the velocity changes, so delta v over delta t. Okay, so in the question, they ask us for the speeding up phase. So if we look at the velocity curve here, we know that we're going from 0 to 0.2 seconds, or from 0 to 0.2 seconds, we actually have a speed of 0 meters per second. That means we are standing still for 0.2 seconds. After 0.2 seconds, we ramp up to a speed of about 0.75 meters per second. This is the speeding up phase, the phase in which we ramp up from a smaller velocity to a bigger velocity. And then we see that after we reach this velocity, we actually ramp down back to 0. So if we draw a line from the top point here to a point here, we would say that this lies between 0.2 and 0.4. So roughly, just looking at the plot, this would be like 0.27, let's say. So we don't know the exact value, so we are approximating it. And then on the y-axis, this falls somewhat right in the middle of the velocity curve. So we can say this is 0.75 meters per second. So now, based on our formula for acceleration, the change in velocity would be the final velocity, which is 0.75 minus our original velocity, which was 0. And the change in time would be from we went from 0 to 0.75 in 0.27 minus 0.2 seconds. Okay, so our acceleration is essentially equal to 0.75 minus 0.07. So it's important to note that for the acceleration time, we actually didn't take it from 0.27 or from 0 to 0.27. We actually were, the rate of change of velocity during the first phase, which is 0 to 0.2, was actually 0. So we were not accelerating. We started accelerating when we hit the 0.2 mark. So that's why when we are calculating acceleration, we only have 0.27 minus 0.2 for the delta t. Okay, so if we solve that, we can get the final answer. So they have taken the delta or the time to be 0.266, which is also correct. And then the velocity is 0.075, or the delta velocity. So our final answer in this case would be 12,007 is about 10.7 meters per second square, is equals to 10.7 meters per second square. It's very important to note that we write down the units. So the units for velocity, as we knew, were meters per second, and then we divide that by the units of times, which were seconds. Therefore, acceleration becomes meters per second square. All right, so let's just review this answer as well. Acceleration is the rate of change of velocity with respect to time. The amount of time is 1/3 of, sure. Acceleration during the speed of phase is perfect. So this answer is correct. Let's head over to our second question. So the second question is asking for how much charge does a collection of these many electrons have? So if we're given one electron, let's call this, it has a charge negative. One electron we know has 1.602 times 10 to the negative 19 coulombs of charge. So that's one electron. But now if we have a whole bunch of electrons, so we have a lot of E minuses in a group together, to the extent that this number reaches 1.25 times 10 to the 19 electrons, the way we would find the overall charge is we would take the charge of one electron and multiply it by the total number of electrons we have. So therefore we can say total charge is equals to 1.602 times 10 to the negative 19 multiplied by 1.25 times 10 to the 19. So straight away these two cancel out. So our final answer becomes 1.602 times 1.25, which is about 2 coulombs, which is equal to 2.002 coulombs. Okay, so that would be the total charge of these group of electrons. Okay, so given number of electrons, charge, and then you multiply them to get their total charge. So this solution is correct. Okay, off we go to question number 3. So question number 3 is a bit advanced, and we would require to draw a free body diagram for this question. So the question says we have a box floating in fresh water which has density this much and is shaped like a rectangular prism, and the area of the base is 500 meters square, height is 2, so the overall height. When it's empty, it floats such that it submerged 0.55 millimeters into water, and then when we put a mass into it, it floats such that it submerged 1.6 meters into water. So we need to find the mass of the coal which we put into the box so that it submerges 1.6 meter. Okay, so a very important principle which we need to know to solve this question is to first how to draw the free body diagram of this. Secondly, we need to know about buoyant forces. So for question 3, let me see if there's not really. So for question 3, we would so this is the question. What I'm going to do is just draw over this question. So initially we need to find, or we would make the free body diagram of this box, which is subject to buoyant forces because this portion is submerged. So if I have a box, I know the box has some weight. It's not weightless, obviously. So we have a force mg acting downwards on the box. At the same time, since the box is floating, we know that the forces are balanced out. So there's another force acting upwards on the box, which balances the mg force, which is pushing the box downwards in a way. So this force, which is acting on the bottom, is known as the buoyant force, and we will denote that by Fb. So Fb is the buoyant force. So this force is essentially the force exerted by the fluid, which we, by putting the box, dispersed. So the fluid below it is putting a pressure back onto the box. So the way we would calculate this Fb, the formula for Fb is equals to the density of the fluid which we displaced times the volume of fluid which we displaced. Okay, so now since we know that this free body diagram or this box is in equilibrium, or it's still, we know that these two forces would cancel out, which means they're equal to each other. So we can say that F buoyant is actually equal to mg. As we said above, F buoyant is nothing but the density times the volume. Now, volume is actually nothing but, in this case, we have the area which we have displaced is equal to the portion of the box which is submerged in water. So we have this portion of the box which is submerged in water, and we're given the area and the height. So this portion is submerged in water, so we'll just draw that in blue, and we are given this height h0 equals to 0.55, and then the area is equals to 550 meters square. So the volume is nothing but the area times the height. So we can replace the equation above and put it in a different form. We can say rho times, or sorry, my right. Density is equals to mass. Density is equals to mass over volume. So volume becomes let me just make sure. So rho g v. Okay. So this buoyant force has the, since it's acting against gravity, has the term g in it as well. So continuing from where we left off, we said the volume is equal to the area times the height. So if we substitute that in this case, so this is rho, so we get rho times g times volume is area times height is equals to mg. So all we've done is we've taken this equation and we've substituted the fact that the volume is equals to area times height into this equation. If we look at the two sides, we know that the gravity portion cancels out. Therefore, rho times A times h naught would be equal to m. So m in this case is the mass of the overall box, because initially we have not put in any additional weight. So m to begin off would be the mass of the box. So as you would know, we are given the values of all of these quantities. So we know that the density is equal to 1000 times area, which is equal to 550, and then the height, which is equal to h naught equal to 0.55. Therefore, we can call this the mass of the box is equal to the product of all of these, which is 302,500 kilograms. So it's a very, very, very heavy box. Okay, so that's essentially the first case, but the question was asking for the mass of the coal in kilograms. So in the second case, where we added another mass on top of this M, we added some coal, M1. So now the free body diagram becomes, we have the downward force of M1 plus M times G, and then we have a different buoyant force because it's still being supported of FB acting on it. So in this case, M1 plus M times G is equals to FB. M1 plus M times G, we know the buoyant force is equal to the density times G times the volume. Okay, now continuing from there, M1 plus M times G, we know that the volume is nothing but the area times the height of the water which we have dispersed. In this case, this height is equal to h1, which is given in the question. The two g's cancel out, so we're left with m1 plus m is equals to rho times area times h1, and we can solve for m1 by saying that would be the difference between these two quantities. So now we have the numerical values of all of these, so we can go ahead and solve for m1. We know the rho is 1000 times area is 550, and h1 is actually equal to 1.6 minus 302 500. So 1000 times 550 times 1.6 minus, so 577500 is the answer. So that's the total amount of coal which we put in, 77500. That's a 0. So for the second part, we are asked how far would the barge submerge in meters if M2, which is the mass of the coal, is changed and it's now 250,000 kilograms. So for part B, we are saying that M1, which is the mass of the coal, is actually different and it's equal to 250,000 kilograms. So again, if we were to draw a free body diagram of this, we would still have the mass of the box, so mass of the box M. We have a different M1 in this case, and we would be having a downward force M plus M1 times G, and we would still be supported by the buoyant force. So in this case, we're actually solving for H. So we're given M plus M1 G is equals to rho G A times H. So the G's cancel out. M, which was the mass of the box, did not change, and we had calculated M to be 302 500. So this equation becomes 302 500 plus 250,000 is equals to rho, which was 1000. The area did not change either, it's still 550 multiplied by height. So we would solve for height in this case. So we would have the left side, we would add, so 0, 0, 5, 2, 5, 5 divided by 1000 times 550 is equals to h. So we would solve this. So 552500 divided by 1000 times 550. So the answer came out to be approximately exactly 1 meter. So basically what that means is, if we have a box of 302,000 kilograms, and if we add coal of 250,000 kilograms to it, our box would be submerged by approximately 1.004 meters in water. Okay, let's go ahead and verify the solution. So the buoyant force is FGV, rho GV, mg, that's perfect. So the first answer, 577,500 is correct. And the second answer is also correct, 1.004 meters. So both the answers are correct. Okay, so let's get into the fourth question. So this is a, I believe, multiple choice fill in the blank questions. So the first one is, which color has the longest wavelength? So we're given red, blue, green, and orange. So the answer to this question is red. And one quick way of remembering it is that any color which has the longest wavelength is more visible from the farther you go. So that's why if you see a lot of the stop signs or a lot of the danger signs are actually painted in the color red, just to make them more visible. So the answer to part 1 of question 4 is A, red. And the way to remember this is danger signs. Okay, so part 2 of this question asks for gamma rays, X-rays, visible light, and radio waves are all type of. So all of these have two components. One is an electric component and the one is a magnetic component, which is why these are all type of electromagnetic radiations. So the answer to question 2 is D, electromagnetic radiation. So how electromagnetic radiation works is essentially it's an oscillating wave which has two components, as I just said. So one is the electric component, okay. So this is, let's say, the electric component, which oscillates with the same frequency and same altitude. And then we also have an electric component or a magnetic component which has the opposite phase, but all the other properties are the same. So the altitude is the same, the frequency is the same. Yeah, not very artistic, but I hope you get the idea. So this actually oscillates in the opposite direction, and this is the magnetic portion. Okay, so that's the answer for part B. So the third part asks for the fact that light can exert a pressure on matter suggests that it is made up of particles called electrons, protons, photons, or neutrons. So light is actually made up of photons, and they exert, even though they are massless, they exert a pressure on matter. So the answer to part C, or for the third question, is C, photons. Okay, so let's verify these. So red light has the highest wavelength. All of these are solution of electromagnetic radiation, and we have C, which is made up of photons. Okay, on to the next question. Question number 5. How do I calculate the wavelength from energy? So if we recall, we know that the energy of any particle is directly proportional to the frequency of the particle as well. I believe Planck was the one who discovered a constant which is named as Planck's constant. It's denoted by the letter H. And it helps us equate the two. So we can say that energy is actually nothing but Planck's constants times frequency. If we wanted to get to the wavelength, so wavelength is equated by the speed over the wavelength is equal to frequency. But this question asks for how do you calculate wavelength from frequency, so we would substitute this in the above equation and we would solve for lambda. Hc over E is equal to wavelength, where H is the Planck constant, E is the speed, and C is the speed, and E is the energy. Okay, so lambda is equal to Hc over E. That's correct. Question number 6. What quantity is represented in unit of joules per coulomb? So in this question we're given 3 units and we'll be using the division of the two to find out what is represented by those two quantities. So we know that joules is a unit of energy, and coulombs, like we used earlier in the session as well, is a unit of charge. So if we divide the two, we would have the energy required to move 1 unit of charge. It's actually defined as the voltage. So if we have a battery, the battery creates a voltage difference between 2 points, and it forces electrons or charge to move from one point to the other. This is essentially known as the flow of energy per unit charge. So voltage is equals to energy over charge, or is equals to joules per coulomb. Okay. Now second one is coulombs. So coulombs, like we said above, is a unit of charge. And then second is a unit of time. So charge per unit time, or the rate of flow of charge, is known as the amperage or the current flow, or spindle current. So if we again use the above notation, if we have a certain charge flowing through the circuit and the rate of change of this charge would be known as current or amps. So current is equals to charge over time, and it has the units amps. Okay. Third, watts per second. So watt is a unit for power. So power is watts, and then time is seconds. And then when you divide the two, so power over time is actually the amount of work we have to do. So again, uh, you can think of this as watts per unit second, or the amount of seconds required to do 1 watt of power. So this is the work. Okay, so the first one was potential difference or volts. The second one was current or ampere in this units, and the second final one was watt per second or energy or work done. Okay, next up, question 7. Is force a vector quantity? So if we look at the force, the formula for force is equals to mass times acceleration. And we know that acceleration is indeed a vector quantity. That's why we denote it by this arrow on top. Force is actually a vector quantity as well. So when I say vector quantity, what do I mean? A vector quantity is something which has two properties, which has a magnitude and a direction. A magnitude is essentially any physical quantity or which has some value. And direction is it's direction sensitive, so it can be positive or negative. Speed, on the other hand, which is a scalar quantity, only has magnitude, and it's therefore a scalar quantity. So what I mean by this is we have the x and y axis, and if I have a particle here which is being pushed in this direction by some force, we would say this force is positive since it's acting towards the positive x direction. Similarly, if we have a positive particle here which is being pushed in this direction, the magnitude of the force is F, but the direction is negative since it's in the negative x direction. So because of this property, forces can cancel themselves out. So like we did in the example for the buoyant forces, we might have a mg acting downwards on a body, but we have an equal and opposing buoyant force which is acting on the body as well. So while mg is negative because it's in the negative y direction, the buoyant force is actually positive, and this is equal to 0 since they balance each other out. So yes, indeed, vector force is a vector quantity, and it has both a magnitude and a direction, and we need to be wary of the two. So vector quantities have both magnitude and direction. So we can have two types of forces: balanced force, so they balance each other out, or imbalanced forces. So imbalanced forces would essentially mean that you have any shape A, you're moving it by a force F, and it's actually moving in this direction. So basically, whatever friction force this may have, F from friction is not able to counter the force F and is causing it to move. So in this case, we would say F minus FF is not equal to 0, and it will be equal to something mass times something. Okay. So this answer is correct. What is the rate at which velocity changes is called? So like we saw in the plot previously, if we have a velocity time plot, and if we have it increasing linearly like this, the rate of change or the slope of this curve would actually represent the acceleration, which is also defined as delta v over delta t, and can be called as the rate at which velocity changes. It's important to note that both velocity and acceleration are vector quantities. Therefore, depending on the slope and the direction, the acceleration can be positive or negative, and similarly, the velocity can be positive and negative as well. So the time rate change of velocity is called acceleration. So this answer is correct. Okay, so question number 9. So question 9, a solid aluminum sphere of radius r has moment of inertia I about an axis through its center. The moment of inertia about a central axis of the solid aluminum of radius 2r would be. So in this question we're given for a sphere, just draw a circle actually. Let's do this. So for a sphere, so this is the sphere R. So just imagine this as a 3D shape. So for this sphere, we're given the moment of inertia. So the inertia is the resistance to motion essentially, or the resistance for body to stay in the state it currently is in. So if you're moving, you would want to stay moving, and if you're still, your body would want to stay still. So moment of inertia about a central axis, in this case it will be the moment for rotation. So if we have a central axis passing through the sphere here, we know that the formula for the moment of inertia is 2 over 5 mr squared. Okay, now the question asks if we have another sphere, but in this case the radius is actually 2r, so 2 times the radius of this other sphere, what would be the moment of inertia in comparison to the original one? So this is equal to I1. So we know that I2 is equals to, let's call this R1 as well. This is R1, this is R2. So actually this will become R2. Okay, so the moment of inertia for the second sphere is nothing but 2 over 5 mr2 square. So it looks like its radius, and if you square it, multiply by m times 2 over 5, I get the moment of inertia. However, we know this relation as well, that R2 is nothing but 2 times R1. So if I substitute this R2 value inside this equation here, I would get I2 is equals to 2 over 5 m 2 R1 squared, or I can say it is equal to 2 over 5 m times 4 R1 squared. So now if we look at this value here, we know that 2 over 5 m R1 squared is nothing but I1. Therefore, we can say if we rearrange and we look at this carefully, we can get this form: 4 times 2 over 5 times m times R1 squared, and then this everything in the bracket is nothing but equal to I1. Therefore, we can say that I2 is nothing but 4 times I1. So since you have a sphere which is twice the radius of the original sphere, the moment of inertia about an axis through the center becomes 4 times of the original moment of inertia. So let's see, the moment of inertia is 2 or 5 mr square, and for another sphere with radius 2r, it would become 4i. So option B in this case. So this is correct. Okay. Question 10. It's taking a bit of a second here to load this question. Okay, so we're back up. The question is finally loaded. So question number 10 asks for, if the light strikes the first mirror at an angle of theta 1, what is the reflected angle theta 2? So for this question, we need to know the law of reflection. The law of reflection essentially states that if a light beam is incident on a mirror at a certain angle theta, let's say, the reflected angle forms the exact same angle with the mirror. So if we just write it down in simple form, we say, according to the law of reflection, angle of incidence is equals to angle of reflection. From this principle, we know that if we have this mirror arrangement like in the question, and if a light beam is incident forming an angle of theta 1 and it reflects back at forming another angle theta 2, theta 1 is actually nothing but equal to theta 2, just based off the law of reflection. So the two quantities are actually equal. So the answer is theta 1 equal to theta 2. Explanation: according to the law of reflection, angle of incidence is equal to the angle of reflection. So the answer perfect. Question 11. Consider a charged parallel plate capacitor. How can the capacitance be halved? So we have a parallel plate capacitor. Capacitors are used to store charge. So we have a parallel plate capacitor. The capacitance of a capacitor is actually given by this formula, epsilon times A over D. This is called the permissivity. And it's more dependent on the material than anything else. So for different capacitors, we would have different permissivity. The other two factors which kind of dictate what the capacitance would be the area. So this, I've drawn it in one dimensional now, but if you look at this in two dimensional, it's something like this. So this area would also determine the capacitance of our parallel plate capacitor. So this is area A, and then the distance between the two. So the closer they are, the more charge they will be able to store, and the further they are, the smaller capacitance they would have. So we know that capacitance is dependent on these two or these three, whereas E naught is constant. So if we wanted to halve our capacitance, we would have two cases. So case one would be new area would become old area divided by 2. So you would have much smaller areas for the new capacitors. So these new areas are equal to area over 2. This would give us the new capacitance is equals to epsilon naught A over 2D, which is also equals to C over 2. C was the original capacitance. And then the second case would be, since we've already modified the area, if we were to go back to the original scenario and actually use distance, nu is actually equal to twice the original distance, we would have the same downward or halving of the capacitance. So if we have the same big parallel plate capacitor, but we now actually move them apart such that the new distance is equals to twice the original distance, it would have a similar effect on the capacitance. So the new capacitance C dash would become epsilon naught A over 2D, which is nothing but C over 2. So the two ways you can have capacitance would be by either reducing the area by 2 or by increasing the distance between the two parallel plates by 2. So by the changing the area to A over 2 or the distance to 2D, capacitance is halved. So this answer is correct. Alright, on to the next question. Question 12. Define spring constant. So we know that by Hooke's law, the force exerted on a spring or by a spring is directly proportional by the displacement of the spring. So question 12. If we have a spring here, and if I'm exerting a force on the spring, F, and let's say the spring compresses now, and this distance of compression, which it originally had, is x. So the more it compresses, the more this spring wants to push the force back, or the more resistance it generates to the force. So this resistance force is essentially directly proportional to the amount of displacement. So we can say the restoring force from the spring, or F spring, is directly proportional to the displacement. It's also important to note that this resistance force is in the opposite direction of displacement, so we have a negative sign here as well. So in order to justify, or in order to equate these two, we have what's known as the Spring's constant, which is denoted by the value K. So Spring's constant, and Spring's constant is essentially dependent on how stiff the string is, or spring is. So if you have, let's say, a spring which doesn't have a lot of winding, so that spring is essentially going to be less stiff and would have a smaller K value. So therefore what that would mean is if you push it together, you would get lesser resistance. Whereas if you have a spring which is thicker and let's say has more coils or more number of rotations, that spring would have a bigger K value, and hence when you try to compress it, you would get a bigger force. And then if we just solve for K, we would have Fs over X, and the dimensions are in newtons per meter. So that's the definition of Spring's constant. Is a constant, in other words, the stiffness of the spring is. So yes, it's directly related to the stiffness of the spring. So the solution is correct as well. Question number 13. How does energy change from one form to another? What are some examples? So, if you would know the first law of thermodynamics, it essentially states that energy can neither be created nor be destroyed. It can only be transformed from one form to another. So the key word here is the word transformed. So for question 13, according to the first law of thermodynamics, we say that energy can neither be created or destroyed. It can only be transformed from one form to another. Okay, so a quick example for this is if we have, let's say, a small box on top of an incline. So if we have an incline and if we have a small box over here which is standing still, this box at this point is exerting this force mg downwards, and it's at a height of h. We say that at rest this box has a potential energy which is equal to mgh. As we let go of this box would slide through this incline and would come down on the floor and be still, or would be moving, I apologize. When it comes down, it converts all of its potential energy into kinetic energy. So as it comes down, it would be transferring its potential energy to kinetic energy, which is given as half mv squared. So it initially had potential energy, then it would have kinetic energy. Since the object cannot continue to move, it would stop, and it would be emitting energy and converting kinetic energy into frictional energy or heat energy. So as you see, the energy which started out from potential energy keeps getting transferred to other forms of energy. So in this case, we're not creating energy or destroying energy, we're just transferring it from one form to another. And if you were to think that, oh hey, how did the box get to the top of this incline? So someone had to do work or to put the box on top. So someone had to use their physical energy, let's say, to put the box on top of the incline. So again, that's another example of converting one form of energy to another. Okay. Energy can neither be created nor be converted. So burning fuel to transform into kinetic energy. That's correct. Okay, next up, question 14. Two boats start together and race across a 460-kilometer wide lake. Okay, so let's quickly draw this out. So you have boat A and boat B, which race across this lake, which is 60 kilometers wide. Okay, boat A goes across at 60 kilometers per hour and returns at 60. So if we have a boat A, it goes at 60 kilometers per hour and returns at 60 kilometers per hour. Okay, whereas the board B goes at 30 but returns at 90 because they're lagging behind. So board B goes at 30 kilometers per hour and returns at 90 kilometers per hour. The first question asks us which board would win the race and by how much time. So let's see. So let's divide it in two phases. One is the phase where we're going initially. So initial phase, we know speed is equals to distance over time. So time would be equal to speed is distance over time. So time is distance over speed. So for the boat A, if we call it dA, is equals to distance over speed of A. And we know that the distance was 60 and the speed was 60. So we got there in 1 hour. Similarly, the initial phase for the board B, the distance was the same, but the speed was different. So 60 over 30 is equals to 2 hours. And for the second phase, when we would return phase, we can say the time taken for A for that was again distance over speed, which was constant. The speed did not change. So we took 1 hour to come back. Similarly for B wanted to catch up this time. So they increased their speed now from 30 to 90. So it took them 2/3 of an hour or 0.66 hours to come back. So they were a bit faster to come back than boat A. But the total time for A would be equal to the initial phase and the return phase. So it's equal to 1 plus 1 is equals to 2 hours. But similarly, the total time for the board B is equals to, initially it took us 2 hours to go, like we calculated, but to come back it only took us 0.66, which is equals to 2.66 hours. So therefore, since time taken by board A was less, board A won by 0.66 hours. So 0.66 hours, or you can multiply it by 60 minutes per hour and say that it won by about 40 minutes or 39.6 minutes. Winner is boat A. Alright, and we don't have much time here, but part B, what is the average velocity of the winning boat? So the average velocity is calculated by the total distance over total time. So we know that the total distance over total time, which was 120 going back and forth, and we took 2 hours. So the average speed is 60 kilometers per hour. Okay, so let's make sure. So boat A won by around 40 minutes. That's what we got as well. And then to complete for the average speed, it's total distance over total time. So it's 60 kilometers per hour. So this solution is okay. Alright guys, I think that's everything for today. Thank you so much for tuning in to OneClass. This was Nehel. If you did like the video and would like to be notified for future updates, or if you have any further questions, please feel free to like, subscribe, comment with any of your questions. And if you need help with one-on-one tutoring or any of your personal questions, there's a description below which you can check out OneClass. Thank you so much and have a good day.